All right, so for our calculations, we're going to look around our Costco parking lot and do a random sample of 62 Costco shoppers. We found out that 39 of them own Subaru cars, right? So that's going to be our yes. Yes, I own a Subaru car, or no, I do not. And the question we want to ask is, what is the 99% confidence interval for the true mean of the proportion of Subaru ownership for Costco shoppers? All right, so we saw that X was 39. That was the number of yeses. The number of no's is our sample size, 62, minus my number of yeses. 62 minus 39 is 23. Okay, number of yeses, number of no's. And the important thing for us is that these are both greater than 10. That means the central limit theorem applies, and we can use the standard normal distribution approximation. So we can use these for our critical values for calculating our confidence intervals. So the next thing we need to calculate is our proportion. Right? So X over N, the yeses over the total sample size, is going to be our proportion value, and that is 39 over 62, so out to 4 decimal places, this is 0.6290. 62.9% of our sample owns Subarus. All right, so our P hat was 0.6920, our N was 62, and we're asking for a 99% confidence level. Our critical value for 99% confidence level is 2.576. Okay, so that's the thing that's going to go in our margin of error. All right, so our margin of error is our critical value times the square root of P hat times 1 minus P divided by N. In this case, 99% confidence, 2.576 times the square root of P hat 1 minus P hat over N. This comes out to be, out to 4 decimal places again, 0.1510, right? So we're going to look 15.1% on either side. All right, so now let's start calculating our confidence interval. P hat minus M, 0.6920 minus 0.1510. This comes out to be 0.5410, right? So over 50% is our bottom here. On the high end, we're going to add our margin of error. This comes out to be 0.8430. So the statement we want to make is the following. Right, we are 99% confident that the true mean proportion of Costco shoppers that own Subaru is between 0.541 and 0.843. Okay. Now, when we talk about statistics, one of the things that we typically like to look for is this idea of majority. If the entire proportion is either above 0.5, right? So if the bottom is greater than 0.5, or if the top is below 0.5, we can say something about whether or not it's reasonable to assume the majority do have a thing or the majority do not have a thing. If 0.5 is in there, we can't say much about the true majority. But in this case, since we have an entire interval that's greater than 0.5, right, the bottom is 0.541. It's reasonable to assume using this data that the majority of Costco shoppers own a Subaru. Okay? Whether or not that's a real assumption is entirely different, but based on this data, that is a reasonable assumption to make. Now let's talk about sample size. Okay, so if we are confident that our P hat that we've calculated is reasonable, right? Or if we've done a little information ahead of time. But now we want to talk about shrinking our margin of error, right? We choose some confidence level, right? And the critical value associated with that. we can find what sample size we need to get a particular margin of error m. So the calculation for this can be gotten out of the margin of error calculation. Just reverse it and solve for n. The calculation we end up with is that our sample size is going to be our p hat times 1 minus p hat times our critical value divided by our allowable margin of error, and then we square just this piece. Okay? This part was under the square root with the n, so we don't need to do anything else with this. It's p hat times 1 minus p, and then we square this fraction. So if we wanted to go back and ask, all right, what's the minimum sample size to have a 90% confidence error, a 90% confidence level for margin of error to be only 0.5, right? If we only want to have a 5% on either side, how big must this be, assuming that our p hat is reasonable? So doing our calculation, right, we have p hat, we have 1 minus p hat, 90% confidence is 0.1645. Our margin of error is 0.05. We do that fraction, we square the result, multiply it by this thing, and we get that this is 230.7005. And again, we want to round that up to 231, right? When in doubt, make the sample larger to get a smaller margin of error. But this was assuming that we had information about p hat to begin with. If we can't do that, what do we do? All right, so if we are not confident that p hat is reasonable, or we haven't taken any data at all, right? We take our confidence level and we assume kind of a worst case scenario for p, right? We assume that it's exactly 50-50, and this is always going to be our worst case scenario. Okay, so the calculation to get our sample size assumes that our p is 0.5, 1 minus p is also going to be 0.5. 0.5 times 0.5 is actually 0.25. So if we don't have any idea at all about what p hat is ahead of time, we just assume that it's half, right? This will give us the largest sample size for a given margin of error that we want. Okay? So again, right, what's the minimum sample size to have a 90% confidence and a margin of error of 0.05? So in this case, to 271. Okay? So if we could actually use the result, we had 231. So our sample size is larger if we can't make that assumption, right? This is our worst case scenario. So when in doubt, assume the worst case.